Hello, everyone. Welcome to today's webinar. It's titled Enabling Successful Contemporary Tile Installations. I'm Jim Olson with the National Tile Contractors Association, and I want to welcome you and thank you for taking time out of your busy schedule to attend today's program sponsored by Progress Profiles. Before I introduce today's speakers, I want to remind you that during the webinar, you'll be muted. Please use the questions area on your control panel to type in any questions during the presentation, and we'll answer them at the end. If the audio on your computer is poor, please call the number on the invite to this webinar and listen on your phone. That should make it much better. All NTCA webinars are available to watch at any time on the NTCA YouTube page. YouTube channel. Shortly after the webinars are presented, it will be up there and ready for you to access, giving you the easy access to watch and or share all current and past programs at your convenience. All right, today I get to introduce a new speaker in our webinar series, Brandon Howard. He is the technical sales representative for Progress Profiles. He's been with Progress Profiles for about 5.5 years. He covers the Southeast and the United States. He began working in the tile industry in 2003 as an apprentice under his brother. Through those years, he learned the fundamentals and importance of installing tile according to industry standards, which is very important to the NTCA. In 2013, he became a certified tile installer through CTEF. He started his own tile and remodeling business and was successful working alongside his son until he decided to make the move to Progress Profiles. Welcome, Brandon. I'm very excited to hear your presentation today and looking forward to it. Thank you.
Well, thank you very much. Thank you for having me here.
You still here?
Yes, sorry, can you hear me?
No, I can hear you now. Okay.
Okay, all right. Sorry about that. I just want to thank you for having me here, Jim. Thank you to the NTCA, and I have a lot to go through, so I guess I can go ahead and get started. All right, so today we're going to be going through enabling successful contemporary tile installations with the purpose and learning objectives. So the purpose is in order to address tile installation difficulties effectively and avoid failures. Designers and specifiers must maintain full awareness of current knowledge, practices, and products. This course reviews potentially problematic contemporary tile installation issues along with the industry guidance, methodologies, and products available to address them. The learning objective is that at the end of this program, we want you to be able to determine the probable cause of tile installation failures or problems, identify and avoid potential issues that could lead to tile installation failure, leverage industry research and experience to address contemporary tile installation issues, and select and specify the correct methodologies, standards, and products for successful, durable, safe, healthy, and aesthetically pleasing installations. All right, section 1. Successful tile installations dating as far back as thousands of years are still relevant today. So what are not so evident are the failed installations. Failures are sometimes attributable to lessons learned by the tile industry as it catches up to the construction industry. Lessons learned are reflected in current codes, handbooks, best practices, standards, new products and techniques, and manufacturers' recommendations. Recently, there has also been an evolution of aesthetic preferences leading to a current preference for large tiles and narrow joints. As well, an ever-increasing focus on energy efficient and occupant comfort in buildings has steadily raised the demand for and the technology of heated floors. This training is a little bit older, so heated floors are definitely catching on. This course will summarize key contemporary construction and aesthetic issues, possible failures and their causes, and the guidance, methodologies, and products that can address them. It is important to note at the outset that certain failures such as cracked and popped tiles could be attributable to one or more of several causes, and that an expert examination is often required in order to determine the correct causes and solutions. Tile installations must conform to the International Residential Code for residential applications and the International Building Code for commercial installations, as well as local building codes. Anything below these standards is illegal. However, the tile industry often has much more restrictive standards that should be followed to avoid failure, litigation, and designers and installers, tile installers, must become familiar with them. Tiles, for example, should be ASTM 1155. Refer to ANSI specifications, the TCNA handbook, and an NTCA reference manual for further guidance. The ASTM 1155 test is a standard test method for determining the floor flatness and floor levelness of concrete floors. The tile industry has stated concentrated load requirement beyond building codes, 300-pound point load causing deflection less than 1/360th of a span. And of course, the concrete industry has differing flatness standards than the tile industry. Pictured here is one of the number of industry publications that can assist designers, specifiers, and installers to avoid problems and produce problem-free installations. And this is available online for reference. Other sources include ANSI accredited standards. ANSI is a private, nonprofit organization administering and coordinating the U.S. voluntary standards and conformity assessment system. The ANSI ASC A108 committee is made up of professionals from the manufacturing, installation, sustainability, and use of ceramic and glass tile sectors. It works to develop standards defining tile installation, as well as their test methods, physical properties, sustainability, and installation materials. These voluntary standards are intended to serve as a guide to the general public, manufacturers, distributors, and other in the tile industry. Voluntary standards represent industry best practice and should be followed in detail. These guys have worked hard to put this together, so they did all the legwork. We just have to learn. There are numerous guidelines, tests, and standards available from other organizations, such as the ones pictured, that cover all kinds of installation environments, including those that are particularly challenging. For example, outdoor applications with drainage concerns and possibly freestalling cycles. Their advice represents the collective experiences of thousands of professionals over many decades and is invaluable as a resource. It is important to follow these guidelines and standards in detail and to use the most stringent standard available. The advice that is most critical, however, is that which comes from the manufacturer. Their technical specification sheets from particular products in specific context trump all other instructions. Designers should consult manufacturers to ensure that they are using the right product and using it appropriately. Equally important to success is the experience, expertise, and qualifications of the tile installer. With accelerated construction schedules and an emphasis on price control, semi-qualified or unqualified installers are often contracted, then pressured to work at a pace that restricts them from doing their most careful work. Tile installers should have an accreditation, such as the available from Ceramic Tile Education Foundation or Tile Installer ThinSet Standards, and verification through University of Ceramic Tile and Stone. Tile installers should not only verify their certification, but also confirm that they are familiar with and will carefully follow the relevant guidance from codes, standards, and handbooks. Some negation of the industry standards is the industry standards for tile flatness and lippage do not apply if the owner does not supply a substrate that meets flatness tolerances or fails to instruct an installer to the correct flatness by grinding or floor filler, etc. The issue of who is responsible for the final condition of the substrate must be carefully spelled out in specification. So the slab in the picture, for example, shows little promise of meeting tile installation requirements. The necessary remediation responsibility could lead to on-site disputes, delays, and cost extras. All right, we'll go to substrates. In the case of failure or problems, the tile itself is not very often the issue, but it can be. If the tile meets the ASTM C648 for breaking strength and passes the 250-pound force specification of ANSI 137.1, then the issue is not likely the tile, but is most likely something else, such as the substrate condition. And on the right, you'll see the standard test method. It goes over that. Verification that tile meets these criteria should be provided by the tile supplier. Such verification helps narrow down the cause of any problems that may arise. Some common substrate issues. The tile setters must install on top of the work of others, and the condition of surfaces provided for tile installation often does not meet tile industry standards. Specifiers should make it clear who is responsible for bringing surfaces up to tile industry standards and are asked for repair allowance in the tile bid. Specifiers should also obtain a written statement from the owner as to anticipated usage in order to predict live loads, impact loads, and concentrated or point loads. For example, commercial installations should pass level 14 of the ASTM C627 Robinson's floor test, which measures the durability of the entire tile system. So the level 14 Robinson's test is the highest one achievable. It requires a system to sustain a rotational rolling load with 300 pounds on each 3 wheels for 30 minutes without cracking. So that's 450 rotations at 900 pounds of total load on steel wheels. Subfloor not properly prepared or assessed. Non-level floor can lead to lippage and cracking issues. Excessive deflection can lead to cracking. The type of quality of finish on concrete subfloor, a broom finish is what we require. The type of subfloor, differential movement of the subfloor, and the concrete substrate not properly cured. Curing usually takes about 28 days, and everybody's in a hurry, so a lot difficult to wait. Some potential installation failures illustrated here can be attributed to poor substrates, but may have other causes as well. Cracked tiles in the first picture is the most common failure of all, often due to ongoing shrinkage of substrates. Cracked grout, which is in the second picture, often happens first with wood framing due to excessive deflection. We should always check for proper joist placement. Excessive lippage, which is not on, but it does kind of show in picture 3. And then tinted tiles, which is in picture 3, is often caused by the shrinkage of the substrate, and loose tiles. So some new construction substrates, which is a cementous screed in concrete floors and slabs. The screed refers to both a tool and or a thin top layer suitable for other finishes. Floor screeds are self-leveling, viscous mixtures that flow into the low points. And when sufficient material is poured, result in a perfectly flat and level upper surface. The adjacent image is of a screed pour in progress. Note that the screed must still be smoothed further, or more material needs to be added. You can see in the lower right corner where they still have some old concrete there. Cementous floor screeds, pre-mixed mortars with a cement binder, share issues with concrete slabs and floors. So some of those screed and slab issues. Substrate subject to expansion, contraction, bending, and deflection. As a result of changes in moisture content and loading will fluctuate over the life of the building structure. The coefficient of thermal expansion of concrete is close to twice that of ceramic tile. Concrete shrinks during the first 28 days of curing. Tile on young concrete may be susceptible to damage, such as tinning and cracking. Concrete slabs are subject to deformations caused by changes in moisture, temperature, and loading. Concrete slabs on or below grade are subject to moisture migration. Slab texture must enhance good bond performance for thin-set mortars, such as steel trowel or broom finish. The International Concrete Repair Institute has a concrete surface profile system on concrete surface preparations and methods of upgrading the surface. NTCA, in conjunction with ASCC, NWFA, and FCICA, has a joint position statement on flatness and texture in their 2015 and 2016 NTCA reference manual. I'm sure they have an updated version. And debonding agents left on concrete surface may require shot blasting to remove. Gypsum-based screeds are based on a binder of calcium sulfate rather than cement. Generally, they are pump-applied flowing screeds, and there has been a growth in the popularity of their use when installing underfloor heating systems. There should be at least 25 millimeters of screed for this usage. They are also used as floor levelers and thermal barriers. Gypsum screeds require fewer movement joints than cement screeds. Joint locations should be decided during the design stage, and the design should be verified by the manufacturer. These screeds are easy to lay, low cost, fast drying, pumpable, self-leveling, and offer minimal shrinkage. While gypsum-based screeds are suitable for tiling onto, there are a few extra critical points in their preparation. They are not generally recommended for areas with consistent dampness. And then some of those screed issues are when a cement-based adhesive is applied directly onto the floor, the cement and the tile adhesive reacts with the gypsum and the screed, resulting in a mineral called adringite being formed at the interface. The associated structural change is sufficient to cause a complete debond of the cementitious adhesive away from the screed base. As anhydrite cures, a weaker layer of lateness is formed on the surface. This layer is too weak to tile onto and also slows the drying time of the screed. Lateness can be removed by light abrasion using a suitable sanding machine 4 to 6 days after the application of the screed. Scarifying the surface is even recommended with low lateness calcium sulfate and hydrite screeds, as it further aids adhesion. If a screed is known to be anhydrite, it can also be thoroughly sealed before the application of the cement-based tile adhesive. Check with your manufacturer for appropriate approaches. If the screed type is not known and is believed that it could be anhydrite, the screed should be thoroughly sealed as a precaution. You have to ensure that the floor is fully dry. The residual moisture level should be less than 0.5%. Drying times vary according to the brand of screed used. Some are designed for fast track use, while others require the standard drying times. If no other information is available, assume the screed will take 1 day per millimeter up to 40 millimeters in thickness to dry in normal conditions. Screeds thicker than 40 millimeters will require 2 days per millimeter. So what are the potential failures that can be attributed to poor substrates? Cracked tiles, cracked grout, excessive lippage, tinted tiles, and loose tiles. Another substrate is OSB and plywood. These substrates are most commonly applied over wood joist framing. Structure and joist placement spacing should be checked for adequacy. Substrate is subject to expansion, contraction, bending, and deflection as a result of changes in moisture content and loading, and will fluctuate over the life of a building. Wood will expand at different rates than ceramic. Wood is susceptible to moisture damage. Installing a cement backer board, an additional layer of plywood, or an uncoupling membrane, also called cleavage membrane or slip sheet, over the substrates is generally recommended. Some older substrates that are existing, designers are often, or tile guys, are often asked to update an existing installation of older materials with contemporary materials. Such requests often come with budget restrictions that eliminate the possibility of removing an existing installation completely, and generally only the finished surface is visible. Any hidden issue already inherent in an installation can be inherited by a new surface application unless it is separated by an uncoupling membrane. The existing installation must be analyzed carefully by an experienced professional. The new application may require any or all an uncoupling membrane, movement joints, as per any new installation, refers to the TCNA handbook, appropriate joint sizes, and possible reinforcing of the substrate. Another one is existing vinyl and asbestos tile floor issues. When applying a new tile surface over an existing vinyl tile substrate, the following must be carefully considered. The surface must have an acceptable flatness as per new floor. The surface should be scarified or sanded to achieve proper bond. An uncoupling membrane is recommended and will compensate for any future movement in the existing substrate. Existing finished flooring must be well attacked, clean, free of wax and other bond breakers. Only one layer of existing floor should be present. New tiling should not go on foam-backed flooring or on flooring that is perimeter glued. Adjustments may be required to existing doors and stairs. The manufacturer's instructions and product recommendations must be followed carefully. Another one is existing ceramic tile floor issues. In general, it is fine to tile over an existing stable tile floor provided the following are taken into consideration. The existing tile floor should meet all the requirements of flatness, lippage, deflection, etc. for a new floor. A tile leveling system may be beneficial or necessary. The existing installation must be free from problems. Cracks suggest an underlying issue, and it may reappear in the new floor. An uncoupling membrane allows new installation to have an independent movement joint pattern. The existing tile must be soundly bonded, clean, and free of grease. The substrate and structure must be capable of supporting additional weight without increased deflection. Issues of higher floor level at doors and stairs, etc. should be addressed. Use the appropriate tile adhesives or thin sets. Should always check with your manufacturer. And then, of course, follow the manufacturer's advice and product recommendations. All right, go into some movement mitigation. Movement causes. It is inevitable that tiles will be subject to movement stresses. Therefore, there must be movement joint system to accommodate them. Guidelines for a movement joint layout can be found in detail in EJ 171 of TCNA handbook. It is especially important to note that for interior installations, movement joints are placed more frequently when moisture or direct sunlight is expected. Tile exposed to direct sunlight in one area will expand differently from tiles in a shady area. Darker tiles will expand more readily than lighter tiles. Tiles in wet areas will behave differently from those in dry areas, etc. Such as like four-season rooms. You have to treat those with expansion joints just like you're outside. In small rooms, a gap at the perimeter of the room, usually hidden by the baseboard or skirting, is often sufficient. For larger areas, the movement joints will be visible and their pattern can become a design feature. Some of the movement causes, many things that can subject the tile layer to shear forces in addition to temperature swings and moisture. These forces can also cause tile installation movement. Tile is a facade. Movement joints eliminate stresses that occur between the substrate and the tile due to their differing amounts of expansion and contraction from any of the following causes. Continued curing of the concrete substrate can put tile in compression and cause cracks. Deflection and vibration of the substrate, particularly with suspended slabs and wood framing. Seismic activity, changes in the plane of the substrate, weight-bearing columns. Tile cracks from deflection are sometimes referred to as deflection reflection. And you can see on the diagram on the right where it shows the load in the middle pulling away and where it's cracking. All right, possible failures due to movement. Failures are similar to those associated with improper substrates. They include tinted or popped tiles, loose tiles, cracked tiles, and cracked grout. Tiles heaved off the floor are tinted, like in the picture, and sometimes cracked are often a sign that the movement joints were insufficient. For tile over concrete, the curing, or the shrinking of the concrete places the tile under compression. How long it takes the tile to tint is directly a function of at least three variables. The rate of concrete shrinkage, the shear strength of the thin set, and any expansive forces applied to the tile, such as heat. When the tile is poorly bonded, the tile can tint very quickly. If there is a strong bond, often the grout will compress significantly before the tile will lose its bond. Of course, the type of tile is important as well. All right, dealing with some movement joints and control joints. Note that nomenclature referencing movement joints varies. Control joints, sometimes called expansion or contraction joints, are designed to induce controlled cracking caused by drying and chemical shrinkage at pre-selected locations. They are typically formed by saw cutting, tooling, or through the use of inserts. Control joints are used in a fresh screed. By putting lines in the fresh screed, you are forcing the cracks to form in the desired controlled areas. If a control joint is established in a concrete slab or screed, it must be carried through the same location in the tile joints, or an uncoupling membrane must be used to allow differential movement. Note the saw cut does create a ridge, so you do have to address that, but also the movement, the uncoupling membrane doesn't take away the need for expansion joints. You just can, be more selective as to where you put them, but you still will need them. All right, movement joints allow relative movement of the coverings or the tiles themselves. This type of movement is a greater magnitude than the managed by the control joints. Thus, the fittings are different, wider, and differently configured and more noticeable. Movement joints are filled with a material that allows for contraction and expansion. For floor applications, urethane, neoprene, and polysulfide are most often used as the filling material in traffic areas. Silicone is sometimes used where traffic is not a concern, but in traffic areas require a sealant with a shore hardness of 35 or greater. Expansion joints, sometimes called structural joints or movement joints, are joints dealing with the greatest magnitude of movement. Expansion joints are joints required for static or engineering reasons, and they divide large buildings into various movement segments. Expansion joints permit both horizontal and vertical differential movements attributable to thermal and moisture expansion contraction. As well, they provide resilience to building sway and seismic activity by providing a complete separation between all materials to allow for free movement between adjoining parts of the structure or abutting surfaces. They are typically placed at columns, walls, and other restraining surfaces, but may appear in the center of large spaces. Joints must run vertically in one continuous plane through all load-bearing and non-load-bearing parts of the building, and in specific width from footings to roof membrane and through every material in between, including the tile, coverings, and screed construction. All right, review question. What are the causes of tile movement? The continued curing of concrete, deflection and vibration of the substrate, seismic activity, changes in the plane of the substrate, and weight-bearing columns. We'll get into tile warpage and lippage. Tile lippage is the vertical displacement between two adjacent tiles of ceramic, glass, or stone tile installation. One tile is going to be higher than the other. Lippage is more frequent today and has a number of causes that include an uneven substrate surfaces or improperly prepared surfaces, lack of tile setter expertise or qualifications, installation methods, like direct adhesion versus full pack mud like a dry pack, or wet set. Large format tiles, spacing or separation of tile modules, tile patterns, tile warpage, and tile thickness variation. Some tile lippage issues. Excessive lippage can lead to a number of problems. Tile edge with excessive lippage is prone to chip. Your furniture and appliances can get caught and again chip the tile. And also excessive lippage is a safety hazard for elderly, vision impaired, or me for being clumsy. Tile lippage is an inherent characteristic of installed tile. There are some applications where tile lippage to some degree is unavoidable. ANSI A10802 cautions that lippage requirements don't apply to tile floors sloping to drain, specifically when using the tiles that are 6x6 and larger. You should avoid the use of spot bonding or 5 spotting to control lippage. Spot bonding is the usage of 5 dabs of mortar versus full tile mortar coverage. It leaves voids under the tile that can crack or split and with slight impact. It also produces a hollow sound. Lack of full thin set coverage is a major cause of failure, especially for large format tiles. NTCA provides the following advice. ANSI A108.5 states that the average uniform contact area shall be no less than 80%, except on exterior or shower installations where contact area should be 95%, when no fewer than 3 tiles or the tile assemblies are removed for inspection. The 80% or 95% coverage shall be sufficiently distributed to give full support to the tile. And our picture on the right is not showing directional trialing, so it's a little bit showing what not to do. We should always do directional trialing so we can correct it, collapse our wedges. Tile warpage is a decreasing occurrence in contemporary tiles. When a tile is warped, all the corners cannot be set in the plane of adjoining tiles. The ANSI A137.1 standard defines allowable warpage according to the type of tile. For a paver tile commonly used on floors, the allowable warpage is defined as follows. When measured as described in ASTM C485, the warpage of the tile in the sample shall not exceed 1% along any edge or 0.75% on either diagonal. An allowable warpage per ANSI A137 ranges from approximately 1/32 to 3/32. The standard lists a number of other considerations regarding warpage and lippage and their relationship in tile joints, etc. So here are your tile lippage tolerances. There are tolerances for tile lippage. The ANSI A108.2 standards say that acceptable lippage for floor tiles with a grout joint width of 1/16 to less than 1/4 is 1/32, plus the allowable inherent actual warpage of the tile. Allowable lippage is the total of the inherent actual tile warpage plus the allowable lippage from the adjacent table. You can refer to the TC&A handbook for ceramic, glass, and stone tile installations for specifying and specific installation methods. But you can see on the right, the little table, how it has tile size, and then the joint width, and then the allowable lippage, and the lippage is very minimal. We do have deceptive tile lippage. Lighting conditions may give an exaggerated and incorrect impression of lippage. Certain light angles, such as those parallel to the tiled surface, create shadows, especially on highly reflective tiles that highlight and amplify even acceptable lippage. Sometimes a light placement will cast shadows and it looks like there's lippage everywhere. All right, we can get into some other contemporary conditions. Moisture vapor emissions, MVE, from high vapor pressure, damp concrete or wet soil, to low vapor pressure, dry building, may upon reaching impermeable materials, vinyl coatings, and certain tiles, collect, condense, cause moisture damage, discolor natural stone or tile, and reduce functionality of adhesives, grouts, and membranes, and or can cause efflorescence. Contemporary tile installations are more vulnerable to MVE. Historically, tile installations involve tile that was more porous, and in many cases the installer used debonded cleavage membranes in conjunction with a wire reinforced mortar beds. These factors buffered the tile installations from moisture. Excuse me. Tiles are now often bonded to concrete slabs that have been covered with a waterproofing and anti-fracture membrane, making installations more convenient and successful but less breathable. Schedules are more ambitious than ever, which means installations may take place before concrete moisture levels are completely stabilized, and concrete often absorbs water from the ground. It can also absorb water vapor from the air in humid conditions. Ongoing exposure to moisture. Ongoing exposure to moisture is a condition found in like baths, showers, pool rooms, decks, spas, and steam rooms, etc. Floors in such spaces, no matter how they are constructed, require a waterproofing membrane to protect finished spaces below and to avoid loss of bond between the tile and the substrate. Installation also requires careful attention to the number and placement of movement joints. In high moisture situations, such as the indoor pool room, a greater number of movement joints are required than in a dry space. All right, so hydrostatic pressure is created by a high water table and by emergencies such as broken pipes, heavy rains, or sudden snowmelt. They all create pressure under the basement slab or against the wall and force water through cracks and or lift the slab. This is different from the moisture problem. The amount of hydrostatic pressure is relative to the height of the water table above the point the water is being forced in. In the accompanying diagram, the pressure is greater at the bottom of the wall and under the slab because the water table is at the top. It can cause the tiles to debond or tent, and lifting pressure is greater than the tensile strength of the bond with the slab. An uncoupling membrane on the slab will sometimes mitigate this condition, especially for short-term emergency situations. Rectifying the core or ongoing issue usually involves one or more of the following: implementing an interior or exterior foundation drainage tile system, full basement waterproofing, pumping, and or under slab vapor retarder. Once again, expert advice is needed. All right, construction schedule and pricing pressures. Accelerated construction schedules combined with competitive pricing often result in imperfect work. Imperfect work includes floors not smooth enough for tile installation or not sloped properly for waterproofing. Repair necessitates fillers, grinding, and shot blasting, and results in added cost and delays. Specifications must clearly describe who is responsible to bring the floor to acceptable condition and or allow repair allowance in the tile budget. This aids in avoiding arguments, extra cost, and litigation. Aggressive scheduling also generates difficulty in waiting for full concrete cure and settlement. It is critical to check with manufacturers when products can be applied and or whether an uncoupling membrane is recommended or necessary. Contractors should verify when and where curing and flatness tests were conducted. All right, let's go into some contemporary trends, products, and solutions. Today's preference for larger tiles along with smaller joints has implications on tile installation criteria. Substrates must have a stricter levelness criteria. For example, larger tiles can only have an 1/8 of an inch deviation in 10 feet, whereas smaller tiles can have a 1/4 of an inch in 10 feet. Even when a slab meets overall flatness requirements, there can still be localized high and low points, and these can be problems in direct proportion to tile size. Measurements should be taken when the slab is fully cured and away from columns, etc., where slabs tend to curl. There is a greater tendency for lippage. Larger tiles require special thin sets, like a LFT. Tile leveling systems are highly recommended and can not only improve accuracy dramatically, but can increase productivity by as much as 60%. Another contemporary trend is radiant heated floors. Heated floors are also ancient. There are numerous instances of Roman bathhouses and villas using this concept. The technology, however, has changed totally. Radiant heat goes directly to a body or object that does not try to warm the entire air mass of a space. Thus, these systems provide greater comfort at lower ambient temperatures and are more energy efficient. The result is more comfortable and healthier environment. Tile is an ideal surface, finished material to distribute this gentle heat evenly. Currently, there are two basic types of radiant floors: hydronic, which is water-based, and an electric cable. Hydronic is usually used for larger areas. Electric is typically used for single rooms like bathrooms. Hydronic installations require a thicker, like concrete slab, gypsum screed layer to accommodate the flexible PEX tubing that circulates to warm water. Electric radiant heat can be included in thinner, lighter construction, and the cable can be laid into thin set layer or incorporated in some waterproofing uncoupling membranes, like the ones pictured. You should always consult the industry handbooks and standards for advice on extra movement joints when installing in heated areas. All right, contemporary fittings. Contemporary fittings are in general sleek and smooth as compared to the round and shaped ceramic fittings of traditional installations. They also come in a wide range of metals, wood, and vinyls. Profiles and fittings can not only enhance the aesthetics of any installation, but they also perform multiple functions, such as they provide a finished look to any installation, they hide control gaps at the wall and floor junction, they bridge uneven surfaces in floor installation, they protect the edges and corners of the exposed tile edges, and also they hide some tile joints. Another contemporary fitting is stair nosing. Stair nosing are designed to serve several functions. They protect the edge of the step. They hide the joint between between the tread and the step riser. They ensure durability of the tread and riser because it protects from chipping. It provides a cleaner look. It improves the clarity of the stair edge for the vision impaired. It's less prone to slipping, and it enhances decor because they come in different colors and profiles and materials. Another one is cove bases and skirting boards. Like many contemporary fittings, bases and skirting boards perform multiple functions. They hide the open tile joint between the wall and the floor. So by hiding this, you create an expansion gap between the two elements. In some rooms, this is necessary to accommodate movement due to expansion and shrinkage. They make it cleaner, easier. They make cleaning easier and better. They have different functions, like they can incorporate the LED for increased safety. They can carry a small wiring like computer or telephone cables to tuck those away. They enhance decor. They come in a wide range of material and colors to suit every installation, such as stainless steel, titanium, aluminum, vinyl. And also they come in a range of profiles: protruding, flush, flat, curved. We also have countertop edges. Countertop edges contribute to the health, safety, durability, and aesthetics of the kitchen. Countertop edges hide the edges of the tile and cover any dirt and attracting joints. They extend the durability of the tiles by eliminating chips from impacts at the counter edges and the corners, and chips are unsightly and difficult to clean properly. They provide a tight, easy to clean edge that improves the ability to keep surfaces sanitary, and also the metal edges add to clean, smooth aesthetics. And we also have different flooring transitions. The transition fittings have multiple functions that contribute to health, safety, and aesthetics of tile installations. They are essential between floors and differing finished materials, like wood to tile, tile to carpet, vinyl, and such. Their smooth surfaces are beveled or rounded. Profiles make transitions more visible, thus significantly reducing tripping hazards and improving safety. These fittings, they cover dirt trapping joints and improve the ability to maintain a clean floor. They have clean lines, contribute to a good finish look. They're available in many materials, colors, and finishes. We also have corner guards. Corner guards are used primarily as a finishing square for wall installations, but can also be used for countertop edges, raised platforms, steps, bats, and as an edge and skirting board for parquet, natural stone, and different floor coverings. They facilitate laying and eliminating the brittle unpredictability of ceramic tiles. They strengthen tile edges with a square finish, protect corners efficiently, and avoid chipping and breakages resulting from knocks. They guarantee flawless work of great aesthetic merit, and they also have a wide variety of other profiles available to respond to various aesthetic and functional needs. And also, again, we have different types of movement joints, like we went over earlier. So shown here are a few more examples. They have profiles available for different movement conditions, control, movement, and expansion joints, such as the floor edge condition shown at the top image, and the mortar lay fitting at the bottom. And then we also have uncoupling and waterproofing membranes. Uncoupling is also an ancient principle. Roman tile systems used to use a sand layer that evolved over time to thick, heavy mud layer, and then again contemporary membranes. In addition to reinforced mortar, liquid polymer, and cork, there are lightweight, flexible sheet membranes that can perform multiple functions such as waterproofing, uncoupling, heating, and vapor control. Membranes help prevent future issues such as changing moisture conditions from affecting the tile installation. Membranes uncouple tile from the substrate and thus accommodate differential movement between the surface and the substrate. Membranes form a strong mechanical bond between the thin set and the membrane, so those two will move together as a system independent of substrate movement. Membranes protect the ceramic or stone tile from deformations caused by differential material movements. All right, review question. What are the two types of radiant floors? There are hydronic and cable. Again, uncoupling and waterproofing membranes. Membranes eliminate the major cause of cracking and delaminating of the tile surface. They contribute to stiffening wood frame floors. May also provide a waterproofing function by protecting the subfloor, especially wood from moisture. Some membranes have small cavities, leaving some space within the membrane to allow moisture to escape to the perimeter or to the drain. Membranes that are most easily laid, they minimize potential for errors. They're lighter in weight, multifunctional, and are usually the best choice. You should consult the manufacturer for confirmation regarding the correct product for each context and provide as much detail as possible about existing and possible future conditions. Another contemporary product is tile leveling system. We have a lot now. Leveling systems are not a solution for uneven or badly prepared floors. The subfloor must still be prepared properly as previously discussed, and full movement control must be provided. Tile leveling systems are final adjustment and ensure that any small remaining flaws in the substrate in relation to flatness can be perfectly compensated for in the installation. They also reinforce the skill of the installer, making it easier and faster to achieve perfect tile alignment. Tile alignment is especially important for large format tiles that are harder to align. Tile leveling systems improve safety as they eliminate tripping edges like lippage, and they improve the tile durability since eliminating lippage also eliminates the potential for chipped edges. Leveling systems should allow a finite adjustment and readjustment. Allow tile removal and replacement during installation. Use a minimum number of fittings. Be versatile enough to deal with all tile sizes and installation conditions. Allow reuse of fittings and be easy to install and remove without tools. Here is one pictured. There are many leveling systems and a number of commonalities. All have a thin plastic upstand, a leveler, with a base that fits under two adjacent tiles. The upstand also serves as a joint spacer. Each system has a fitting that is lowered down onto or through the upstand. Fittings or caps can be wedged on, screwed on, and off with conventional tools, pushed on with custom tools, or screwed on without tools depending on the system selected. When secured completely, caps align at least two tiles and are placed at the corners or along the edges of the tiles. When the cap is lowered, tightened, or wedged, it brings adjacent tiles' edges into perfect alignment. The upper portion of a plastic upstand and cap can be knocked off or kicked off with a mallet or boot after the tile is fully set. Most systems have reusable fittings or caps. The system shown here in the following slides has a hand screw down system of two elements, the leveler and the cap. It requires no tools. It features reusable caps, which can be knocked off with a mallet or kicked off. It accommodates multiple sizes. It accommodates tiles from 3 millimeter to 40 millimeter. Sorry, the cap can be flipped over to suit tile thickness. One style of leveler pitcher can fit under 4 tiles at corners, and one cap can be aligned with 4 tiles. Some systems must use multiple clips at each side of the tile. Built-in spacers are available to accommodate the cross intersections as well as T-joints and a single leveler, saving up to 3 pieces per joint. And tiles can be lifted and replaced during installation. These systems can work on walls and floors together. They accommodate grout joints from 1 millimeter up to 5 millimeters. They have a vertical compression exerted by the cap reduces movement and widening of the joint. The thin base of the leveler allows for easy placement without mortar accumulation. The shaped hole in the middle of the cross and the T-shaped leveler allow for perfect control and tile alignment. And the holes at the base of the leveler enable a perfect anchoring between the adhesive and the leveler. This is just a sequence of pictures of how they work. And in summary, tile is an ancient and durable finishing material. The ancient basic principles for successful installation are still relevant today. However, installation methodologies and products today are completely differing and constantly evolving. Construction, market forces, complexity, methodology, and technology are all also constantly evolving. The tile industry, through its members, organizations, and testing authorities, etc., monitors these evolutions continuously and conducts ongoing research as to how to best address contemporary conditions. It shares this accumulated knowledge in the form of guidelines, standards, and technical papers. Manufacturers in parallel refine or develop products that follow this guidance and provide further and more specific advice as to their product's appropriate usage. In parallel to these technological evolutions, there have also been both economic and aesthetic evolutions. Today, a floor or wall covering has to do more than just cover the substrate. Floors today are also used to provide comfort and warmth by integrating radiant heat and a light, thin installation assembly. Problematic subfloors that are not suited for tile installation can become acceptable by using uncoupling and crack isolation membrane systems. Builders, designers, and architects are asking manufacturers to provide innovative finishing trims to give the final project a polished, finished look. Today's construction climate is more and more demanding in terms of accelerating speed and lowering costs. These demands make it harder and harder to execute successful installations. The same demands make it increasingly important that tile setters be properly qualified with today's methodologies. At the same time, aesthetic preferences demand larger and larger tiles with smaller and smaller joints. Larger tiles are more difficult and more time-consuming to lay perfectly. This in turn has led to an entirely new system of setting tiles, such as tile leveling systems. The combination of problematic working conditions and more difficult tiles would suggest that tile installation failures would steadily increase. In order to address the difficulties effectively and avoid potential installation failures, designers and specifiers must maintain full awareness of current knowledge, practice, and products. It is extremely difficult for a single professional to maintain the proper level of awareness of every building material on their own. By leveraging the experience of others, current industry guidance, the expert advice from manufacturers as to selection and usage of the correct products in the correct manner, designers, specifiers, and installers can consistently enable successful, durable, safe, healthy, and aesthetically pleasing contemporary tile installations. And here are just some resources of where we got all the information that we used. And that is it.
I just really wanted to thank you for all this information. It's amazing how much information there is on profile edges, underlayments, heating systems, whatever. At this time, we really don't have any questions, and I think it's because our attendees probably need some time to go through the PowerPoint one more time and the presentation one more time. They can see it on the NTCA YouTube page profile, and should be up by Thursday, and everybody can watch it. Brandon, you had a lot of information there, and I hope our attendees take the time to review it. It was a great job, and I want to thank you. Appreciate
No,
it.
thank you. Thank you for having me here. I really appreciate the time, the opportunity.
All right. Well, thank you everybody for attending, and I just want you all to know that as I mentioned last week, we have a very busy July when it comes to our webinars. We have another next week, which is the 24th, which is next Thursday, not this coming Thursday, but next Thursday, and another on July 31st. Please look for the invites to those. Have a great week, and I want to thank you all. Take care. Bye, everyone.
Thank you so much.